Hello everyone, welcome back to our channel. So today we are going to solve another problem, which is sliding window minimum. So let's discuss what the problem statement is saying, and then we'll move up to how we'll be going to solve the problem, and then we'll finally see the code of this. So if we read the problem statement, it is saying you are given an array of n integers. Your task is to calculate a minimum of each window of k element from left to right. In this problem, input data is large, okay, and input is being given to us, okay, and output is we have to print the XOR of all the window minimums, okay. So if we understand, if we see what the problem statement is saying, so the problem statement is saying we are given with an array in which there are some elements. Let's suppose it's 1, 2, 3, 5, and let's suppose there is a size of 3. Now what we have to do is the possible sliding windows are from 1, 2 and 3 of size 3 and 2, 3 and 5. These are the two possible sliding windows. Now for this particular window and for this particular window, we need to find the minimum. So minimum for 1, 2 and 3 is 1, 2 and 3. Minimum is 1. And for 2, 3 and 5, the minimum is 2. What we have to output is XOR of 1 and 2. So this is what we have to output. And this is what exactly the question is, and the elements are not given explicitly. They are given in the format of something like x of I is equals to a times a into x of I minus 1 plus b plus b and modulo c. Like this is how the elements are being given to us. So like this won't be a much of a challenge. This is the input that we will be taking, and then the main logic actually is how do we find the sliding window minimum for each of the possible window. Okay. Now if we think of an approach that actually comes into our mind is, let's suppose we are given with an array of size n. Now our challenge is, let's suppose our initial window is of size k. This is a k size window we are talking about. Now let's suppose we know the minimum of this particular window is x. Now the challenge is, when we would be adding this particular k plus 1th element, we are adding this k plus 1th element in the next window and removing this 0th element from my window. Now the challenge is, how do I be saying that whether my minimum would remain x only or it would be some another value y, right? So this is the challenge. If we are able to find this particular thing in an optimal manner, then our problem would be solved, because then we would be expanding this particular logic to the size of n, and we would be then simply sorting out our possible answers. Now to do that, we know a data structure that we actually use, that is a priority queue. A priority queue. If I talk about a min priority queue where for each of the length of the priority queue, let's suppose the length of the priority queue is k, it will always be remain in a sorted fashion of an ascending order, where my topmost element would always be the least or the, I would say, the minimum element. Now if I maintain a priority queue of size k, then my answer would be like, it would be very easy to solve. Then what I will be doing, it would be running an heapify function automatically. Now what I will be doing is, I would be pushing this q dot push x of k plus 1th element, I would be pushing into the queue, and I would be popping this particular element. Now the challenge is, how do we maintain that? How do we know that which element we are popping out? Because we have not stored the indexes of this particular element. So to do that, our priority queue would simply not be an integer priority queue. It would be a pair of integers, which would be storing the value as well as the index idx. So in this fashion, we would be able to perform this particular solution using priority queue, and the time complexity would be around n log n. But this approach would work perfectly for our lead code problems and all of the another coding platforms, but for CSES this would not work and this would give a TLE, because they are very strict with the time constraints. So what they exactly want is a big O of n approach. This is exactly what the problem is actually looking at. I hope you have got the jinx of the priority queue approach, and most of you would be knowing what exactly the priority queue is. And if you want the solution for this particular priority queue approach also, just ping me in the comment section. I would be giving you the code for this as well. Now let's discuss the big O of n approach of how would be actually doing this particular thing. Now to do this, how do I what if I say let's maintain a min stack using two different stacks, like two stacks. Okay, so let me explain you. We would be using two particular stacks, S1 and S2, for which I would be using S1 will be used to push the elements and S2 would be used to pop the elements. Pop elements, and this would be used to as push elements. Alright. Now let's suppose if I give you I'll explain you the order. Let's suppose we are using push 5. Okay, we are using push 5. So push is done on this particular stack, so initial element would be 5, 5. So what we will be storing is, we would be storing the value, comma, minimum so far. This is how our element of a stack would actually look like. If I just scroll it a bit, yeah. So what we'd be doing is, we would be pushing the elements as value, comma, minimum so far, right? Now let's understand this. Now if I have done push 5, so it would be 5, 5, because the minimum till here is 5. Now if I do push 3, so it would be 3, 3, because minimum is 3. Now if I do push 8, it would be 8, 3, because minimum till 5, 3 is 3 and we are inserting 8, so value would be 8 but the minimum so far is 3. So this is how our push operation would be working. And now the question in your mind would be like, how exactly the second stack comes into picture. Now when I'm saying I would be popping elements from the second stack, okay, now let's say when we want to pop the elements from the second stack, what approach I would be using, I would be saying if S2 is empty, then bring all elements of S1 to S2, then remove the top. And if you think it in a in a bit deep fashion, so in this it would be actually be a FIFO operation I would be performing, because in this way it would be working as a queue, because we have you might have read that how to implement a queue using implement queue using 2 stack. You must have read of this particular problem as well. So this is how this is the exact approach that would be actually be using. So like I'll explain you this approach with an example as well. So let's take a particular test case. Let's suppose our array is something like 4, 2, 7 and 1. So this is, let's suppose, our array we are talking about, and our window size is of 3. Okay, now our initial window is 4, 2, 7 and our next window is 2, 7, 1. Okay, so now let's see how it would be using that. So if I talk about S1 and S2, this is my S1, this is S2. Initial element is 4, so minimum till 4 is 4 only, so we would be pushing 4 comma 4. Now the next element is 2, so what we would be doing is we would pushing 2, and minimum till 2 is 2, so it would be 2 comma 2. Now we would be pushing 7, so when we are pushing 7, so 7 would be pushed, and the minimum till here is still 2, so it would be 2. Now we have inserted k elements, like the window size elements, into our stack. Now the operation is that we have to push 1, but we have to pop 4 as well. So in that particular case, what we will be doing is, now we have to pop the element 4, but popping can only be done from stack 2, and stack 2 in this case is empty. So what we would be doing is, we would be pushing the elements from S1 to S2. So if we talk about the order of this is not the order of S1. So order of S1 would be topmost element this, then this and this. Like we know the stack, okay? First and last out principle. So if we talk about if we talk about the insertion order in S2, we would be inserting 7. So if we insert 7, so minimum till 7 is 7 only. Now if we insert 2, it would be 2 comma 2. And now when we would be inserting 4, it would be 4 comma 2. Now this is the topmost element of S2. And what we have to exactly do is, we have to remove this particular element 4. So we would be removing 4 out of here. And what we'll be exactly be doing is, we would be pushing 1. So when we are pushing 1 into the stack, so what exactly the minimum till here is, minimum was till here is 2. But now the element we are pushing is 1. So minimum would update to, minimum is 2 comma 1, which would be 1. So we would be pushing 1 comma 1 into the stack. So this is now how our S2 stack would be maintained. And finally we would then S2, the topmost element of S2 would always be giving me the minimum element of window, and then I would be simply simply take XORs. So this is how our exact approach we would be using. We are exactly implementing a priority queue or a queue using a 2-stack method. In this particular case, our time complexity would actually be big of n, because there is no heapify function we are using. So it would be boiled down to big of n approach. Now if we see the code for this particular problem, now if we see, we have taken int, n, k, abc and all inputs, and we have maintained the input array vi, a into vi minus 1 plus b modulo c. And this is the first case when we are pushing the v elements, first k elements into the stack S1. So if we talk about the push function as well, we are maintaining a current minimum, which could be, if it's empty then it would be the same element, or if it's not, then we would be checking the previous minimum value, and then we are pushing that value into the S1 stack. Now we have pushed the first element, k elements, into the queue or into the S1 stack. Now we are actually going and asking for the minimum value, what is the minimum value for the first sliding window of size k. Now let's go, if stack 1 is empty, go and fetch for S2, and if S2 is empty, go and fetch from S1 simply, or else it would be going from S1 and S2 and finding the minimum value, whichever would be minimum, I would be returning that. And then here comes the operation where would be first popping out the out of bound value and then pushing the current value that we have to push into the stack. So if we talk about the pop function, so this is how our pop function would look like. First we would be pushing all the elements from stack 1 to stack 2 in the insertion order by finding the current minimum and then pushing them into the S2. And then finally, if it's S2.empty is if S2.empty is not, S2 is not empty, then S2.popback would be simply the topmost element I have to pop. And then finally getting the minimum for each of the sliding window and taking the XOR. So this is how our entire code would look like. I'm sure that you have understood what exactly and how do we are actually solving the sliding window minimum. And in this in this videos, like in the continuous videos, I would be solving much of the problems of sliding window and posting them as well, so that you would get a complete glimpse of how exactly the questions of sliding window are being solved. So stay tuned and do subscribe the channel. Thank you.